Top load test versus box compression test. Why they are not the same tests? At first, these two machines look almost identical in functionalities. Both compress a specimen between two platings, both display force. So why can't you test a PET bottles on box compression tester or evaluate a corrugated box using a top load tester? Because although the motion appears similar, the engineering principles behind these tests are completely different. The load path, structural behavior, failure mechanism, test objectives, and acceptance criteria are all unique. Understanding compression. Compression simply means applying force in one direction. However, successful packaging design depend not only on amount of force applied but also on how that force travels through the structure. Different package geometries distribute stresses differently. A bottle transfers load through its cylindrical shell, while a corrugated box transfers load primarily through its vertical corner columns. Top load test. Top load testing determines the maximum axial compressive load that a rigid container can withstand before permanent deformation or structural collapse. Rigid plastic containers behave as thin-walled cylindrical shells where structural stability depends more on geometry than simply material strength. As compression begins, the bottle first experiences elastic deformation. With increasing load, localized shell buckling occurs, followed by plastic yielding and ultimate complete structural collapse if loading continues. The compressive force enters through the closure or neck finish, travels through the shoulder sidewalls and finally reach the base. Every geometric feature along this path contributes to bottle's top load performance. Critical design parameters include bottle diameter, wall thickness distribution, shoulder angle, neck finish, stretch ratio, rib design, vacuum panels, base geometry, and polymer material. Even a slight modification in shoulder geometry or wall thickness distribution can significantly increase the critical buckling load without increasing resin consumption. Top load testing is widely used for PET bottles, HDPE bottles, PP containers, pharmaceutical bottles, cosmetic containers, aluminum cans, jars, and closures. Industry testing commonly follows ASTM D2659. Customer-specific beverages protocols and relevant product specification. It should not be confused with ASTM D642, which is intended for shipping containers. Now the box compression test. Unlike bottles, corrugated boxes behave as lightweight structural columns designed to withstand stacking load during storage, warehouse, and transportation. The objective of a box compression test is not simply to crush the box but to determine the maximum stacking load it can safely sustain before structural instability occurs. When compression begins, the applied load is transferred through the top flap into four vertical corner columns. These corners act as primary load-bearing members of the box, while the center panels mainly stabilize the structure. Failure can occur in several forms, including corner buckling, panel bulging, fluid crushing, adhesive failure, score line failures, or complete global collapse. Common international standards include ASTM D642, ISO 12048, and TAPI T804. Side-by-side comparison. Although both tests apply compressive load, they evaluate completely different engineering behaviors. Top load testing evaluates the axial stability of thin-walled containers during filling, capping, handling, and transportation. Box compression test evaluates stacking strength to ensure safe storage and palletization through the supply chain. One measures shell stability, the other measures column strength. Understanding this distinction allows packaging engineers to select the appropriate test for each application. So the selection guide, selecting the correct compression test, is not about choosing the machine, it is about understanding how your package carries load. If the package is designed to resist axial compression force acting through its body, a top load tester is appropriate choice. If the package is intended to withstand stacking load during warehousing and transportation, a box compression test should be performed. Using the correct test method leads to optimized packaging design, reduced material cost, improved product protection, and greater confidence in real-world performance. For more such information, you can contact Presto.